Hi everyone, welcome to GeoNodes Challenge Series, where I dig deeper into the geometry nodes potential to show you what amazing things you can do with this procedural tool that Blender has for animation and modeling. And this will be the fourth part of the project Holographic Planet Map, the one you see in the demo. We covered the stuff that you saw at the beginning, and for today we will be looking at a very interesting particle system, the one that you see inside the mesh, not the one down, the one inside of the mesh. And that's a very interesting thing because even though there is a simple way to do that, I chose something that is a little bit more complex because I want to show you a bunch of stuff that you can use for other projects. So if you missed the previous parts, you can look at the link in the top right corner that appear at some point, or in the description. You can choose to watch from part 1 or any other part that you care about. So one more thing before we start, I always forget about that, but I want to do it. I want to thank all of you that are supporting this channel. Thank you for your support. It's very valuable. I couldn't do it without your support. So if you find the content on this channel valuable, you can help me by subscribing, liking the videos, commenting on them. That's very important because as it turned out, even in this project, we can find out glitches and fix them, and that's going to be best for everybody. And also a good way to support me and also get something cool is to purchase these project files from Gumroad. At the end of this video, I'm going to show you the parameters that I exposed for this part, and then you'll get a chance to see at a quick glance how the project file looks like. Anyway, let's move on. Why I'm saying that this is interesting. And by the way, this is where we left it off. We did all the other stuff that you saw at the beginning. For this video, to make things simpler, I'm just gonna shut down the planet so we are not bothered by it. We will be adding the particles. So let me do a frame, put it here, add a reroute and plug it here. Okay, why I'm saying interesting? Because we will be creating a particle system that has a spherical shape, has the particle distributed in the random fashion. We also have control. We will know exactly the number of particles that we will have, and they will follow the radius of our planet, so they will be in sync. And we will have a very cool back and forth animation on it. So that's gonna be what we will be doing. If you want to get a distribution of in circular fashion, I'm gonna quickly show you. You can of course use a UV sphere or an icosphere. You can plug it here, and then you have this either instance on points that it's gonna create a bunch of instances. Let's take something like a cube, plug it here and make it like really small. Oh, not this one, the size. And you can have it follow the shape, or you can do a point. Where is the menu for the points? Point here. Distribute points on faces, and then you get a random distribution of these points. So in the first case, you can control it sort of, the number of points, by playing with the mesh elements, but you don't get randomization. You have to add it otherwise, and it's kind of difficult to control the number of points. In this method, you get the randomization, and you can make points go inside, so you can fill the volume, but you have no control over the exact number of points. This is a density thingy that gives you whatever. These values are not correlated. So even though it would be just fine for this project, I want to show you something more interesting, how you can create a controlled number of points and push it to a sphere. So what we will be ending up doing is creating a fixed number of points, distribute them in the random fashion in a shape of a cube that encompasses our object. And then we are going to build a mask that will cut everything that it's outside of a sphere, and we will not delete those points, because remember, we want to have a control over the number of points, but we will be pushing those points towards inside. So we will end up with a sphere filled with points. We will know exactly how many points there are, and they will be distributed in the random fashion. So enough talking, let's just start with this. How can we make a bunch of points in geometry nodes? We can take a mesh line. Let's plug it here and add it to our setup. We don't care about the offset, 0 is just fine. And now we have this control for the number of points. So let's do like an integer. I like to, let me just adjust this. I like to color my inputs to green so I can find them easy. And let's say we want like 5,000 points. Great. Now if we look here, we have a mesh with 5,000 vertices. It's a good start. Quickly, because we need the radius of this planet that it's given here, let's expose this value. And in order to avoid long noodles, let's just create a group input. I like to color my group inputs to this bright green so I can easily find it. Drag it here to expose it, and you can find it in the group. You can give it a name. Let's say H. Hologram radius, because this is a hologram. And once we did this, we can simply just Control C, Control V. Hey, Control C, Control V. Okay. Now we have this node here. Let's bring it to our setup, because we will be using this. So now we have a bunch of points, and let me put this one here so we have room to play. We have a bunch of points. Now let's distribute them in a random fashion, forming a cube. And for that, we can do a set position. Always when we want to play with the points, we do set position. And we will be distributing them in a random fashion using a random value, switching this one to a vector and plugging it to the position. And now we can play with the minimum and maximum. And here is where we use the radius for the first time. Let's plug the radius here to the maximum. And for the minimum, we can simply do math, multiply by -1 to invert it. We can use float because we will be playing with simple distribution, simple values, the same on all axes, so that's just fine. Let's call this one invert A, so we can collapse it. And now we have this cube of points. The next order of business is to distribute this in a spherical fashion. And like I said, we want to select everything that is outside of a sphere and push it inwards. So let's start by creating this selection mask. And in order to see things easy, let's temporarily put a delete geometry nodes on points, and we will feed the mask to see if it's working. So how can we create a spherical mask? Let's take the position of the points, and we can do a vector math on it and choose length. That's going to give us the length of the points, and then we can control from 0, basically, length from 0 for each point. Let's do a compare and say that everything that is greater than this value is going to be selected. And what value do we want? The hologram radius. So now we can plug this one here, and voila, we deleted everything that is outside of this radius. One useful control, given the fact that we want this to appear inside of the hologram, is to play a little bit with this radius to make it a little bit smaller than our planet. So right now, if we are to activate the planet, as you can see, points are just going all the way to the edge. But if we subtract a little bit from this radius, let's say like 0.1, we will make sure that points gets pushed inside. Okay, now let's get rid of the planet. Is just clouding the vision. This is also a parameter that we want to modify, so let's leave it like this. And now we want to do something else. We don't want to delete the points, because otherwise we have like 1,900 points from the 5,000 that we initially had, and this is not what we want. So let's delete this node. We're just gonna use this mask. Let me give it a color, plug it here. By the way, I like to put double frames on my masks, make the outside white and the inside a darker color, black and white. That's the mask. That way I can easily find it in my setup. And like I said, we want to push those points towards outside. So if we want to push points, let's use a set position, and we will want to push them in a spherical fashion. How can we do that? Let's take the position of the points. I'm gonna use a vector operation on it, and that's gonna be normalized. That's gonna make the vectors fit into the 0 to 1 range. So if we are to plug this one right now here, what we get is again a sphere where all the points are normalized. Of course, we can add a scale now. So if we have a different radius than 1 for this, we can basically use it. Like this. So we use that value. And right now we get this distribution of points. And if we plug the mask here, we keep the randomization and the points stay put, but we get to push them towards inside in a spherical fashion, only the ones that we selected, something like this. And the effect is different. I'm going to show you again once we do the next part, because for now we did this, how to add the exact number of points, and also we took care of this part to distribute points in the random fashion while keeping the spherical shape. And now we want to do this part, turn the points into a mesh. And for that, let's do an instance on points. We'll do this, and we will be adding the initial cube, plug it here, and of course play with the value, make it like a lot smaller, something like this. And that's gonna give us our particles. And as you can see, points gets distributed inside of mesh very nicely. And if we are to close the mask, you get that we lose the distribution inside because everything gets pushed towards the edges. So the sphere becomes empty because of this normalized node. But if we use the mask, we just push to the boundary this one and create like a nice edge of points here, and everything else inside is distributed randomly instead of having just this edge like we will have without the mask. See? And that's gonna also help us very nicely when we do the animation, because now it's time to go to this part, doing the particle unrest animation. So how are we going to do the animation? Well, let's use an instance, translate instances, and plug it here. And now if we play with these values, we are basically moving the points around. So if we take, for example, the position, I want to show you a very cool animation, like a pulsing animation where the points gets towards inside and then go back, something like this. This is growing and going smaller. So if we plug this one here into the translation, we basically get the double of this value. And if we do a vector math, plug it here, switch it to scale, now we have a controller for this animation, something like this. So at 0, we get the normal value, and at -1, everything gets here. And that means from -1 to 0, we can pulse things to push it from inside towards outside. Why 0? Because at 0, basically, we add no translation. And at -1, we add the translation. In this case, it doesn't matter if you do it in local or world space. So you can leave this checked or unchecked. But if you move this from here, it will matter. For example, if I do geometry transform and I'm pushing this one here, as you can see, it scales towards the center of the world. So keep that in mind. Okay, so basically, if we want to do the animation, the pulsing animation, we have to play with the -1 and 0 scale. So how can we do this? Well, let's add a scene time. And anytime you want an organic movement, you can use a math function, the sine or cosine. So let's use the sine, plug the frame here. I like to hide the outputs or inputs that I don't use. And then we can play this one here. So let's see what happens. First of all, this is way too fast. So let's add the control for the speed. I'm gonna do this as a control. Switch one to multiply, and now we can do like 0.1 and check out. As you can see, we are exceeding the boundaries of our orb, and that's because the sine function goes from -1 to 1. And we want to go from -1 to 0. So we kind of have to remap these values. So let's use a map range node, plug it here, and we have the lower limits -1 to 1, and we want to output from -1 to 0. And as soon as we do this, we get this. Cool. But everything moves at the same time. and that's not exactly really interesting. So let's add a little bit of variation in the speed by using, a random value node. I'm gonna make it also green because this changes stuff. And let's say we want some of the points to go like this and some of the points go like this. At the end, I'm going to show you what values I use for this, but right now we're just going to all eyeball it. So as soon as we do this, we get this cool animation flowing from inside towards outside and back. And we can control the speed here nicely. We can make it go faster. For example, if I put this one like this, and we put this one like, say, 0.5, we get a much faster animation, like you see here. So this is it for this part. Make sure to check out the next part where we will be doing another particle system, the one that motivates the hologram, the one down. It has a different animation, and I'm also going to show you how you can take a shape, any shape, and in that case will be a cone, but you can use any shape, and distribute points inside in a random fashion. So that's going to be different from what we did here. Instead of a spherical thing, we have any shape. And I'm also going to show you how you can create a mask to reveal those points, as you saw in the demo. It's basically going up, growing, and then when it turns off, it goes down. So we will be building a vertical reveal mask, basically. And also that animation that you saw in the beginning, it has a very cool, interesting shape. That's gonna be all that be done in the next video. Now I'm gonna show you the finished project parameters pertinent to what we built here. So you can see a bunch of interesting stuff. So this is how the setup looks on the project available on Gumroad. This is the module that we care about when we have this particle density parameter, particle speed, and particle speed seed. We can play with that. So let's look at these parameters. First of all, the particle density, because you usually use a very large number of particles. I just multiplied it by this value. So a 0 to 1 factor, like we have here, is going to give us a lot more particles. For example, 0.5 is going to give us 5,000. And then we have this particle speed. So if we look at this setup here in the purple frame, where we have the animation, particle speed is going to control the maximum value of this random node, and at 1 you're going to get the highest speed by having the full frame. And if you decrease this, you can decrease the speed anyway all the way up to 0. I also exposed the seed, so you can change the pattern that is created. That's very important. Also, this stuff we did earlier, and I also added comments to the frame, so it will be easier to understand what's going on here. So for this module, this is everything I could show you. Make sure to watch the next part where we will be building another interesting particle system. And of course, then we'll have the last part where we will be talking about the materials, and also very interesting on that one, how can we make these procedural continents that we see here follow the rotation of the planet, because in the shader, I can tell you that we couldn't use a UV map, even though we have this UV map here, because it has a lot of seams, and makes things look very bad. So I used generated texture coordinates, and then I had to correlate that to the shader. But that's gonna be all in the part 6. Until then, thank you very much for watching this part where we cover this stuff that you see here, and also thank you very much for watching this series and for supporting this channel. It really helps me keep making tutorials and improving on them. So until the next video, have a nice day and happy blending. And don't forget, you can post comments and ask questions, and I will try my best to answer them.